Okay, so here we have side angle side congruence theorem, and we're gonna prove it the same way that we did it before. We're gonna start by the same way we proved side side side. We're gonna start by saying, okay, we have two sides here. We have AB and AC. They're fixed in length, and we have an angle A which is fixed in length too. And so you're going to have to construct those lengths. Remember, what you do is you place the needle on one end and an arc here, and then you're going to come down a little bit, and you're going to place your needle over here somewhere and do your arc here on a line, a starter line. And then you've got to measure an angle. Remember, how to construct a duplicate angle is that you put your needle on A, and you would create an arc, random length, it doesn't matter, then come down here and mark that same length. It has to be exactly the same length. From that mark, you're then going to place your needle, and you're going to change your compass's measure so that it exactly reaches where the arc crossed here. So when you draw your arc the first time, make sure you go across AC, this line, both lines. You're going across both lines. So then the second time you come over here, you place your needle here where this arc is intercepting this ray, and then you change the length until it just touches that exact point. You measure that length, you come down here, and from this line you do the arc again at the same point, and wherever those two arcs are intercepting is where you draw the second ray, and you'll have this ray. So you'll have side length AB, and you'll have this ray, and then you come over and you measure AC. Come over here from A, measure it. You're not measuring this with a ruler. Remember, you're doing this with a compass. But you put your needle on A, swipe it, and get the same length for C. Mark C, and then think about how can you complete that triangle. You've got B fixed, you've got A fixed, you've got C fixed. Is there any way to complete that triangle but to draw, CB? You're going to have to just draw CB. And that's kind of your whole point. Once you fixed in point B, point A, and point C, they're fixed, then there's only one way to finish it, which means you're always going to have to go the same direction, so this angle is always going to have to be the same. It's going to come into B in the same direction, so this is going to also always be the same. So you're going to end up with three congruent angles, and the distance between C and B is not going to change as long as this angle is fixed. And that's what your observation is going to be from making your constructions. You're going to compare those side lengths. It talks about, compare to your classmates, but if you're doing this on your own, you're probably not going to be able to, but you're just going to have to notice, is there any other way I could have made that? And then it says, if you're given one of the non-included angles instead of A, do you think everyone in your class would have constructed an identical triangle? So, in other words, if you had the two sides, so B was fixed and C was fixed, the length from A to B is fixed and the length from A to C is fixed, but what's not fixed would be this angle here. Then think about it. If I drew a big circle, right, and C was on that circle, then theoretically, even though this angle here, let's say I had an angle fixed here, I could spin this, keep it on the circle, and just stop spinning it on that circle until that angle intersected it again for a second time. So in theory, just because you have two sides fixed and an angle fixed does not necessarily mean that you're going to end up with congruent triangles, because you can draw that triangle more than one way, or at least you may be able to. Okay? And so we can't just automatically say that side angle is going to work. So this is an angle we call an included angle. It's the angle that is included by the two sides that are defined. And if you have that, you have side, angle, side, and you're going to be congruent. That's the observation that you're supposed to make there. And it says, if you're given one of the non-included angles, do you think everyone would have that you should be able to answer that question now. So you're going to plot your point. You got side, angle, side. You're going to measure your lengths. You're going to do your reflections and your translations. You're going to measure the sides again, and you're going to draw this conclusion that as long as you know the two sides and the included angle, you're going to end up being congruent, and now you have to prove it. So how would you go about proving this? Well, I'll give you some tips. You're going to pretty much want to prove that the angles or the triangles are similar. If you start by showing that the triangles are similar, well, then you're going to be well along your way. So let's think about that. First, how do you know they're similar? Well, this is side, angle, side, and you already know the side, angle, side similarity theorem. And because you have side, angle, side, you know these two triangles are similar. Now, if they're similar, then that means angle C and angle E must be congruent with angle C and B respectively. So all the angles are congruent. And so the only missing piece is this side BE. And what you do know is that the proportions from AC and DF is the same proportion as BC and EF. So AC over DF, if they're congruent, that would equal 1. Therefore, BC over EF must equal 1. And I would write that in there. BC over EF is equal to 1. And then if I multiply both sides by the length of EF, I end up with BC equals EF. Therefore, they are congruent by definition of congruence segments. And by now you have all the pieces by definition. These two triangles would have to be congruent. So that's the way I'd go with getting that proven. So now if you come down, I want you to write congruent statements. So congruent statements are just statements that show that the corresponding sides are congruent. So segment AB is congruent to segment CD, segment BC is congruent to itself, segment BC, and angle ABC is congruent to angle DCA. You got to get good at showing the writing those congruent statements so that you can then, write proofs. Okay, and now you're going to go through a series here. You're going to try and figure out, can I prove whether or not the triangles are congruent? Remember, here you have a side, you have another side that are congruent, two pairs of sides, and the third side should be congruent to itself. So by side, 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 you should be able to get that. Here you're going to have to show that this missing variable, you might call it x. So then you could say that AC is equal to 3 plus x and FD is equal to 3 plus x. As long as you have used the segment addition postulate, then you would have a side, and let's see, the angle and the angle, so side, angle, side, you should be able to prove those, okay? And so now the question is, because we have a shared side, BC, and then we have a pair of congruent sides, BA and BD, and an angle that's congruent, 88 and 88 here, A and D, and Simone is saying then they must be congruent. Remember that the angle has to be between the included sides, and side BD and side AC are not proven congruent, so we can't use this angle. So I think you should be able to figure out about Simone using that information.